Hello, Honors Chemistry students. This is Mr. Spurk, and this is your Chapter 9, Section 4 notes on naming and writing formulas for acids and bases. This is probably the toughest section because naming acids is quite difficult. So, acids are a group of ionic compounds with unique properties. An acid is a compound that contains one or more hydrogen atoms and produces hydrogen ions when dissolved in water. And we will really dive into studying acids and bases later in the year, but we do use them a lot, so we need to understand how to name them and what they mean. So for example, we use hydrochloric acid in our gastric system. It's what helps us digest our food every day. And citric acid is really prevalent in fruits, and carbonic acid is very prevalent in pop or soda. So when naming an acid, you need to identify the anion that is combining with hydrogen to form the acid. So the easiest way to pick out an acid is that its formula will always start with hydrogen. So the chemical formulas for acids are HNX, and that N just implies the subscript for H's, and X is the monatomic or the polyatomic anion. N is the number of hydrogens needed to have a net charge of 0. So again, this is the general formula for an acid. Always starts with H. The name of the acid is determined by the anion. That's the most important thing here. So you need to know your anions. That includes your polyatomic anions. So each rule deals with an anion with a different suffix. So you need to know your IDE, your ITE, and your ATE endings. So in rule number 1, when the anion ends in IDE, the acid's name begins with the prefix hydro. So you take the stem of the anion and it gets the suffix ic and is followed by the word acid. So for example, we have HCl, and this anion, if we were to name just that anion, it would be chloride. So, since it ends in IDE, we need to take the prefix hydro and then add ic. So, what we're looking at here is hydro, the root of our element, which is chlorine, so chlor, and then we add the suffix ic, followed by the word acid. Hydro, chlor, ic, acid. And that's all because the anion ends in IDE. Rule 2. When the anion ends in ITE, the acid name is the stem of the anion with the suffix OUS, or us, followed by the word acid. So here we see hydrogen, and we see our anion. Hopefully by now you know that this is sulfite. Sulfite. So since it's sulfite, we change the ending to OUS. So it doesn't get a prefix. So sulfurous acid. Sulfurous acid. And again, that's because the ending ends in ITE. Rule 3, when the anion ends in ATE, the acid name is the stem of the anion with the suffix ic, followed by the word acid. I always remember this one by you ate something and it was icky. Ate changes to ic. You ate something and it was icky. So HNO3, again, we see that we have a hydrogen out front, so that tells us this is an acid. And then we look at our anion here, and again, we should know that NO3 is nitrate. So 8 goes to ic. This is nitric acid. Nitric acid. So when we write the formulas for acids, you're going to use the rule for naming an acid, but we just do it in reverse. And then you're going to balance the ionic charges just doing the crisscross method like we've done before, because remember that acids are ionic compounds. So for example, hydrobromic acid. So this is where these can get really tough. We have to break this down. We see the word acid, so we know that this is going to start with H+. Now we need to break down this word. We have the root of an element, right? Brom, B-R-O-M. That sounds like bromine. And it tells us, if you remember the rules, that since we have a prefix of hydro and an ending of ic, that this came from an IDE ending. So our anion must be bromide, which is Br-. So the formula of this acid is going to be HBr, because we just crisscrossed our charges. So we really have to know the rules so that we can tear apart those words and break it down. Here is a nice little summary. I really like this chart. I thought to throw it together because it breaks down everything that you're looking for. So where you see the word root, that's where you're looking at the name of the element. And then here we have some prefixes, and at the end we have our suffixes. And here's some examples over there on the right. So this chart is a great reference for you to learn. So there's sort of an exception, and we kind of already saw one with sulfite, and we changed it to sulfurous acid. So with the other ones like nitrate becoming nitric acid, we didn't really change too much, but here this is sulfate, but we don't call it sulfic acid. We add in that UR, so it's sulfuric acid. And the same goes here. This is sulfite, but it is not sulfus acid. It is sulfurous acid. And this is really one of the only examples. There are others out there, but this is one that we will see quite often that doesn't quite follow that change the ending rule. All right, naming bases is really easy because you already know how to do it. A base is generally an ionic compound that produces hydroxide ions when dissolved in water. So it's named the same way as ionic compounds, no extra prefixes or suffixes here. So for example, BaOH2, we just name it just like we would have named an ionic compound. We have our cation and our anion. So BaOH2 is barium hydroxide. And that's naming bases. Writing formulas for bases is the same as writing formulas for ionic compounds. First write the symbol for the metal cation, followed by the formula for the anion, then crisscross to balance the charges. So calcium hydroxide, we should know by now that calcium is a 2+, OH is a 1-. So we get, when we crisscross, CaOH2. And don't forget to put that OH in parentheses since there is more than one. And that's it. As always, all the information on these slides has been acquired and adapted from Pearson Chemistry, 2012 edition of the textbook, the resources CD, and pearsonchem.com. Have a great day.